Hello guys, welcome back to a new video. We have section 2 from chapter 4, changes in temperature and phase. We have specific heat capacity. Specific heat capacity, guys, is the energy needed to raise the temperature of an object or a substance. Imagine you have an empty pan and you have a pan filled with water. Which one would be easier to heat up? Of course, the pan that is empty. Why? Because this pan that is filled with water is going to have a higher specific heat capacity. Or you can put it in another word. You can say that this pan that is filled with water needs more energy to heat up. Okay, so that's why this one has a higher specific heat capacity. Specific heat capacity, guys, is how hard it is to heat something up. Okay, or you can say the energy needed to raise the temperature of an object of 1 kilogram substance by 1 Celsius at a constant pressure. We have the equation for specific heat capacity, Cp. This P denotes constant pressure. Specific heat capacity is equal to Q, which is heat, divided by mass times delta T, which is change in temperature. Okay, Q, which is heat, is measured in joule. M small is mass, which is measured in kilogram. And delta T, which is change in temperature, is measured in Celsius. Careful, we need the temperature here in Celsius, not in Fahrenheit or Kelvin. So the final unit for specific heat capacity will be joule per kilogram per Celsius. This is the final unit for specific heat capacity. Delta T, guys, because it is change in temperature, will be what? Delta T will be T final minus T initial. Okay, you're going to be given the final temperature and the initial temperature, and then you'll calculate the change in temperature. Two important notes: when temperature increases and energy is transferred to the substance, or you can say when the object gains energy, both delta T and Q are going to be positive. And if the temperature of the object decreases and energy is transferred to from the substance to the surrounding, or you can say when the object loses, let me write this down, when the substance loses heat. Okay, when the substance loses heat, this is another way to state it. When the substance loses heat, both delta T and Q are going to be negative. When the substance gains energy and its temperature increases, both delta T and Q are going to be positive. Make sure to memorize this because you will be needing it. Specific heat capacity of some substances. You have aluminum, which is equal to 8.99 times 10 to the power of 2. And you have the others. Water, which most of the time we will be dealing with water, is equal to 8.186 times 10 to the power of, 4.186 times 10 to the power of 3. Or you can just simply write 4,186 joule per kilogram per Celsius. This is the specific heat capacity for water. We have calorimetry. Calorimetry is the study of heat transfer, basically. Okay, it helps us measure how much heat is gained or lost by an object or a substance. Scientists use a special container called calorimeter. This is calorimeter. Okay, for example, if you put a hot object in cold water, okay, calorimetry helps us to calculate how much heat the object gives to the water. Okay, So we have what here? We have energy absorbed by the water, okay? Energy, which is Q W, which means heat of the water, heat absorbed by the water, sorry, is equal to Qx, energy released by the substance, okay? We said if you have an object, you put this object inside the water. The energy that is absorbed by the water is equal to the energy released by the substance, okay? And remember the equation we had, of course, Cp was equal to Q divided by mass times delta T. Rearrange this equation and you get what? You get Q, which is equal to Cp times mass times delta T, okay? And this is basically this one. Cp of water times mass of the water times change in the temperature of water is equal to Cp of the substance or the object times mass of the object times change in the temperature of the object, okay? This equation seems to be difficult, but believe me, it's not. You only need 2 nodes to calculate questions with this equation. First of all, if the substance loses heat, okay, if the substances lose heat, we subtract the initial temperature from the final temperature. We will not say, careful, if the substance loses heat, we will say delta initial minus delta final, not final minus initial. If the substance absorbs heat, we should subtract the final from the initial temperature. So T final minus T initial. Make sure to memorize these 2 points, these 2 notes, as you will be needing them in solving questions. Let's solve this question, sample problem 4A. So it says what? It says an 0.05 kilogram metal bolt made up of aluminum is heated to an unknown initial temperature. Because you have 2 givens, okay, for 2 different substances, okay, make sure to write this one like this, okay? This one is for the metal, okay? This one is for the metal, this one, the metal, and this one is water, okay? So it says what? It says an 0.05 kilogram metal made up of aluminum. So we know mass of the metal is equal to 0.05 kilogram, okay? This is our first given, okay? These are the givens for the metal and these are the givens for the water. Is heated to an unknown initial temperature. It is then dropped into a beaker containing 0.15 kilogram of water. Here we have the mass of the water, which is equal to let's just write mass. You can denote any way you want. I will write MW. You can write for the metal MA and MB for water. It doesn't matter. M of the water, or mass of the water, is equal to 0.15 kilogram. Okay. With an initial temperature of 21 Celsius. Here we have the initial temperature for what? For water. T initial is equal to 21 Celsius. The bolt and the water then reach a final temperature of 25 Celsius. Careful, it says the bolt, the metal bolt, and the water, they both have a final temperature of 25 Celsius. So what should I write here? I should write T final for the metal is equal to 25 Celsius, and also T final for the water is equal to 25 Celsius. Okay. If the metal has a specific heat capacity of 899 joule per kilogram per Celsius, so we have specific heat capacity for the metal. You can write specific heat capacity and write M close to it so not to confuse it with the other one. 899 joule per kilogram per Celsius. Okay, it says find the initial temperature of the metal. Okay, I need to find T initial for the metal. Okay, do I need something else here, guys? Yes, I need the specific heat capacity for what? For water. Specific heat capacity for water is equal to what? Is equal to 4,186 joule per kilogram per Celsius. Okay, now guys, let's solve this question. First of all, we should say that energy removed, it says what? It says the bolt is heated, so we know the metal bolt is really hot. So energy, guys, we can write it like this, or you can just simply write it like this. Q of the metal is equal to Q of the water. Energy, I'll write this here, energy removed from the metal, or energy lost by the metal, is equal to energy gained or absorbed, doesn't matter, gained by water. Okay, now you know Q was equal to what? Q was equal to CP M times mass of the metal times delta T. Okay, change in the temperature of the metal is equal to what? Is equal to CP of the water, again, is equal to, times mass of the water times change in the temperature of the water. Now guys, before we start plugging in our values, our givens, let's first know, are we going to subtract T initial from T final or T final from the T initial? Remember the 2 points we had, guys. It says, if the substances lose heat, we are going to subtract the initial one from the final one. Here, does the metal lose heat or gain heat? Think about it. It is going to lose heat. Okay, so this T, guys, is going to be what? CP M times mass of the metal times, we said it is going to lose heat, so we are going to say T initial minus T final. Careful, whenever a substance loses heat, we are going to subtract T initial from T final. Then CP of the water times mass of the water times water is gaining heat. Okay, so this is going to be what? It's going to be T final minus T initial. Okay, I know you have a lot of quantities to deal with, but believe me, it's really easy. Then let's plug in the values, the givens that we have. Specific heat capacity of the metal is equal to, or of the aluminum is equal to 899 times mass of the aluminum is equal to what? Is equal to 0.05 times. Do we have T initial, guys, for the metal? No, we don't have. We need to find it. Okay, T initial. Do we have T final? Yes, it was the same as the water, which was equal to 25 Celsius. Then CP of the water is equal to 4,186 times mass of the water was equal to what, guys? It was equal to 0.15. Then times T final was equal to what? It was equal to 25. T initial was equal to 21. Okay, calculate all of this. This is equal to what? This is equal to 44.99 times T initial minus 25. Then this one is equal to what? All of this is equal to 4. 25 minus 21 multiplied by this one, you should get 2,511.6. okay, and you should multiply this one by this one and by this one too. So you get 44.99 T initial minus, again, this one multiplied by this one, you get 1,123.75, and then is equal to what? Is equal to 2,511.6. Take this number to the other side. You have 44.99 T initial, which is equal to 2,511.6 minus 1,123.75. Sorry, it becomes, this is minus, so this one becomes positive. This one becomes what? You want to find T initial, so divide this one by 44.99 and divide this side too by 44.99. Okay, cancels and cancels. T initial, calculate this number, okay, add these two and divide it by 44.99. You should get 81 Celsius. Okay, this is the final result. This is the T initial of what? Of the metal. So the metal had 81 Celsius. This question, solving these types of questions takes time, but believe me, it's really, really easy. The only thing you have to do is memorize these two notes that I gave you here. If the substance loses heat, we subtract the initial one from the final one, and if it absorbs heat, then it's going to be T final minus T initial. Make sure to solve this question again, and believe me, you'll be really comfortable solving any question that we will be having in this chapter. This is it for today. If you have any questions, make sure to comment below. Thank you, and see you in the next video.